Treisman's attenuation model in this video. So Broadband's filter model, basically two audio inputs are given like a dichotic listening task, one attended and one unattended message. Now both move through the sensory store. So in this image, as you can see, attended message and unattended message, two basically dichotic listening task is given as input, and they move into the sensory store, move through and are held in sensory store. Now both move through to the selective filter. So from, as you can see here, both from the sensory store move to the selective filter. So selective filter based on physical properties. So it filters based on the physical properties of the messages. So like for example, the pitch, the loudness, the amplitude and stuff. Now unattended message is completely blocked at this stage. So we move here. Now both move through to the selective filter. Only attended message passes on based on physical properties, pitch, loudness, etc. And it then goes to high level processing, which is the working memory. So as you can see, bottleneck here, high level processing, and finally to the working memory. So this is basically the Broadbent filter model briefly. Now graph explanation. Graph is basically the pic that is uploaded above. So inputs are attended and unattended messages. Both attended and unattended stimuli enter the sensory store. So sensory store basically holds raw sensory input momentarily for further processing. Now selective filter filters inputs based on physical attributes like pitch, loudness, spatial location, amplitude, etc. Only the attended inputs pass through the filter for high level processing. Unattended inputs are blocked entirely at this stage. Now high level processing and working memory. Attended stimuli undergo deeper semantic processing. Relevant information is stored in working memory for conscious awareness and use. Now some key features of the Broadband model, which we just discussed above. So early selection, filtering occurs before the information reaches high level processing. Bottleneck, the brain can only process one channel of sensory input at a time. And limitation is that it fails to explain why some unattended information, hearing one's name, breaks through the filter like the cocktail party effect. We move on to the Treisman's attenuation model. So Treisman, here let's see, it's similar to that but a bit different here, because here we have the unattended message does get passed to the attenuating filter as an attenuated message. So let's go to it. Again, the inputs are attended versus unattended message, like in the dichotic listening task. So both pass through the sensory store. Now attenuating filter, unlike Broadband's filter, this model does not completely block unattended stimuli. Instead, unattended stimuli are attenuated, which is weakened, but still processed. Now it moves to the hierarchy of analyzers. So the attenuated inputs are analyzed for contextual or semantic importance. If important, for example, hearing one's name, they are promoted for conscious processing. And working memory, final part, both attended and contextually relevant attenuated stimuli reach working memory. So that's basically what's been described here in the diagram as well. So initially the inputs attended and unattended message, two messages come, just like in a dichotic listening task, pass through the sensory store, moving on to the attenuating filter. Now the attenuating filter weakens the unattended message and the attended message passes as it is, so the bottleneck, and then we move on to the hierarchy of analyzers. So it looks for syllables, words, grammar, semantics. Whether or not attenuated inputs get processed at this stage and to what degree is determined by their threshold. And then finally we reach the working memory. So that's the Treisman's attenuation model. Some key features, it basically is able to explain phenomena like the cocktail party effect, and it resolves Broadband's limitations by allowing unattended stimuli to pass through in a weakened form or an attenuated form. Now we have the Deutsch and Deutsch late selection model 1963. So inputs basically both attended and unattended message pass through the sensory store. Hierarchy of analyzers, all sensory inputs are processed up to the semantic level regardless of attentional focus. Attention acts at the response selection stage, deciding which stimuli to act upon or store. Working memory, only the most relevant stimuli are selected for conscious awareness. Key features, late selection, all stimuli are fully analyzed before attention selects what reaches consciousness. Efficiency provides flexibility in shifting attention based on relevance. Limitation, computationally expensive since all stimuli are processed semantically. Now the flanker task, Erickson and Erickson. Graph explanation, conditions. Noise same as target. Distractors are identical to the target. Noise response compatible, distractors require the same response as the target. Noise response incompatible, distractors require a different response. Noise heterogeneous similar, distractors are similar to the target in features. So I'll be talking about this flanker task in another video in depth. So for now, we'll be moving on to the next topic, which is the bar probe task. And I think I will cover this also in another video. So let's move on to our next topic of the day, which is selective attention concepts. So early selection view, process attention filters inputs at the sensory level. Irrelevant stimuli are excluded before semantic processing. Advantages are it reduces cognitive load by focusing only on the relevant and the significant inputs. Now supporting evidence, dichotic listening tasks where participants cannot recall content from unattended streams. Late selection view process is all stimuli are processed up to the semantic level, and then attention selects the most relevant stimuli for conscious awareness and response. Advantages: explains phenomena like the cocktail party effect and flanker task interference. Limitations are higher cognitive resource demands. Now we'll be talking briefly about the cocktail party effect, which was given by Cherry in 1953. Ability to focus on a conversation in a noisy environment while detecting salient unattended information. It supports the late selection theory as unattended information is processed semantically. Now we've done the broadband. Basically, these are the models of selective attention which we've already discussed in depth above. So I'll be providing the doc link in the description. You can check this out. These are basically some notes that you can make. So, and finally we have the mechanisms. So you can go through these, and I think that's about the video. So thank you guys for watching.